To talk about equivalent ratios and rates. So before we do that, let's talk about when we graph ratios, a ratio table. Describe the pattern in this graph. From this, I can see these are the x-axis about number of CDs. The y-axis are the costs. One CD costs $3. Two CDs, $6. Three CDs, $9. So from my prediction, it's looking like every time you buy a CD, the price increases by $3. So it costs $3 per CD, or $3 for every one CD. So we are going to be doing cup stacking. We're going to have different students compete against each other and stack some cups. So we're just use an example right here. You have a team A, they had 3 students, they finished in 12 seconds. Team B, on the other hand, had 5 students, they finished in 20 seconds. Did Team A and Team B stack the same seconds per student each time? Explain. I don't know. Let's see. I'm not really sure. Let's see. 3 students, 12 seconds. That's like, isn't that times 4? 5 students equal 20 seconds times 4 seconds per student. I will say yes for now. I think it's 4 seconds per student. But express the rate between, because rate is comparison of 2 different quantities with units. Express the rate between the number of students and second as a unit rate in fraction form. A unit rate is when the denominator is 1 per student for every 1 student. So let's start with the first one. So Team A had 12 seconds for 3 students. They want us to turn into a unit rate where the denominator is 1. So how do you break it down, scale down from 3 students to 1 student? Divide by 3, you get 4 seconds for 1 student. Team B, you have 20 seconds for 5 students. I would like to scale it down or break it down from 5 students to 1 student, divide by 5, 4 seconds per student. So use the unit rates, 4 seconds per student, 4 seconds per student. Determine if each pair rates is equivalent. So Team A, they take 4 seconds per student or for every 1 student. Team B also takes 4 seconds for every 1 student or per student. So are they equivalent? Yes, they are. What do you notice? Each team takes 4 seconds for every 1 student. So there are different ways to determine if 2 rates are equivalent. One way is by examining unit rates. If the rates have the same unit rate, they are equivalent. In this example, they are not equivalent. For example, someone loses 15 pounds in 5 weeks or gain 15 pounds in 5 weeks. That's saying they gain or lose 3 pounds per week or for every 1 week. Another person or either gain or lost 12 pounds in 3 weeks or 4 pounds per or every 1 week. So did they gain or lose the same rate? No. This person gains 1 more pound per week or lose 1 more pound per week than this person. So some people like doing unit rates by breaking it down to 1 per unit. So, for example, at H-E-B there are 49 flowers in 7 vases. At Kroger's there are 54 flowers in 9 vases. Are these pair of rates equivalent? So we have 49 flowers in 7 vases. I want to break it down to 1 vase because I want to do a unit rate. So I scale down or scale backward by dividing by 7. I get 7 flowers for every 1 vase. In this one, there are 54 flowers in 9 vases. I would like to scale it down from 9 vases to 1 vase and divide by 9. So I get 6 flowers for every 1 vase. So are they equivalent? No, they are not. At H-E-B, they give 1 more flower per vase or 1 more flower for every 1 vase than Kroger. So I guess they're more generous, or maybe you're paying for it. What about this one? At Hollister, there are 13 t-shirts in 3 boxes. At Forever 21, there are 26 t-shirts in 6 boxes. Are these pair of rates equivalent? So Hollister has 13 t-shirts in 3 boxes, while Forever 21 had 26 t-shirts in 6 boxes. So I want to break it down to one box by dividing by 3, dividing by 3. 13 divided by 3 is 4. I need to get rid of this remainder. We're in junior high. How many 3's go in 10? 3 times. Get rid of this remainder. Junior high, 3 times. You know what? It's repeating. So it's approximately 4.33 t-shirts per box. Like 4 t-shirts, and they cut up 1 2/3. In this one, I want to break it down to one box. So I divide by 6, divide by 6. 26 divided by 6 is 4 times. 2, I need to get rid of this remainder, add a 0.0. How many 6s go 23 times? Ooh, I think it's repeating again. 3 times. So it's about 4.33 t-shirts for every one box. Same as Hollister. So are they equivalent? Yes, they are equivalent. There's another way to do this. Sometimes you don't like unit rates. I'll be honest, I don't like unit rates as much. I prefer to use scale factors. Scale factor is finding, and you're multiplying or dividing by the same number. For example, to turn 13 t-shirts to 26 t-shirts, you multiply by a scale factor of 2. To turn 3 boxes to 6 boxes, you multiply by a scale factor of 2. So from that, I can know that they are equivalent. Or another way is to turn 26 t-shirts to 6 boxes, I break it down, scale back by dividing by 2 and come up with those same numbers. So let's look at these. Which rates are not equivalent? 5 apples to 10 apples times 2. 8 apples to 16 bags times 2. 10 kennels to 50 kennels times 5. 20 dogs to 100 dogs times 5. But let's look at this one. 3 kids to 8 kids. I'm not sure. 7 rooms to 21 rooms times 3. If I put times 3, would this be, should be 9. This is not equivalent. They do not multiply by the same factor. So what happens when you have 2 fractions or 2 ratios, such as these, are equivalent? It is called the word proportion. You're going to be hearing the word proportion for many, many years to come. Proportion says that 2 ratios or fractions are equal to the same thing. For example, is 2/4 equal to 1/2? They are, so they form a proportion. It's when 2 fractions or ratios are equivalent or the same. Equivalent ratios are the same thing as equivalent fractions. So for example, 16 tomatoes to 8 peppers. Is it equivalent to 4 tomatoes and 2 peppers? You can divide by 4, divide by 4, or multiply by fourths, and you get 4 tomatoes and 2 peppers. So they are equivalent. This forms a proportion. They are equivalent. Sometimes we're missing one of the units. So can you find that missing unit and the missing number or quantity? So use scale factor to find an equivalent ratio. For example, here it is. So 4 movies for $9 is equivalent to something movies $27. I want to make a proportion. I want to make them equivalent. So what number should go right here for movies so that they are equivalent? Let's see, it seems like it's building up by 3, so 12 movies for $27. And this one, 5 bows is 25 bows, multiplied by 5, scale up by 5. 3 girls times 5 is 15 girls. And that equals their equivalent. 25 jumps to 100 jumps. I multiply by 4. 3 cheers times 4 is 12 cheers. They are equivalent. So let's try an example. Paint is mixed 4-part blue to 5-part yellow. How many parts of blue do I need if I use 15-part yellow? So I want to make these 2 equivalent. So what number should go here so that 4 to 5 is equivalent to blank over 15? I multiply by a scale factor of 3 and I get 12. 12-part yellow. How many parts of yellow do I need if I use 8-part blue? So let me erase this. 8-part blue. That goes here. So the scale factor is by 2, so 10. And 4 to 5 is equivalent to 8 to 10 proportion. Will 40 parts blue and 25 parts yellow fit the pattern above. Times 10 times 5. Are they multiplied by the same factor? No, they're not multiplied by the same factor. If this had been multiplied by 10, this would have been 50 right there. So let's answer a question. You can buy 3 medium pizza at the pizza place for $12. Or 5 medium pizzas for $30. Do these rates form produce a proportion? That means are these two prices with the number of pizza are equivalent to each other? Let's see. So pizza place, $12 for 3 pizza. The other store sells $30 for 5 pizza. Are they equivalent? You know what? I'm going to make a little chart. I'm going to break this down by dividing by 3, and get $4 for 1 pizza. Then I build it up or scale it up by 5, and I got that. 4 times 5 is 20. Are they equivalent? No, they're not equivalent. Because if you think about it, another way to think about it is unit rate. If you break this down by 3, it's $4 per pizza for every 1 pizza. If you had broken this one down, 1 pizza, divided by 5, it would have been $6 for every 1 pizza. So do they form a proportion? Are they equivalent? No, they are not. So what we're talking about today is you're giving two ratios or two fractions. Can you determine if they are equivalent? Are they the same? You can do it with unit rate by breaking it down to 1 unit. Or you can do a scale factor or by building it up by multiplying by something or breaking it down. Equivalent ratios and rates.